Well, hello again, it's the boring old Git once more, and this time we've got a couple of HP16500A logic analyzers. One which is just being restored and repaired, and the other one being upgraded to a Model B. The Model B is the one at the top in this little video, which is a spoiler of after the restoration. You can see that it's booting up an awful lot faster than the true Model A. So the differences between the two are the Model B uses a much more powerful processor, and also it uses a hard disk rather than floppy disks. The floppy disks it uses also are 1.44 megabytes as opposed to the 720K on the standard Model A. This comes with a slight downside because they're 300 RPM rather than 600 RPM units, so disk access is significantly slower on the B than on the A. The A is really the unloved model of the family. People tend to want Bs and Cs, and As ended up just being gutted for spare parts. Anyway, on with the repairs and renovation. So the first stage is to try firing it up without any floppy disks in it, just to see what errors get reported. Little bit of a wait while the screen comes up, and there we go, no errors but no disks either. So now let's try booting off the front drive. In it goes, didn't feel right, so I popped it out again. Go in, you bugger. Go in. Go in. Go in, will you? Yeah, sort of. Doesn't look right and it didn't feel right, so we'll wait for the screen to warm up. There we go, and no disk, so push it a bit further in. Fire it back up. And here we go, self-test OK, starting to boot. It'll take it a little bit of time to do that. Okay, on to the next phase. And it's a bit out of focus, but there's a CRC error. I suspect the disk wasn't properly in. So let's try the rear disk now. In, no, in, no, in, no. Go in, you bugger. In, you bugger. In. Okay, that's not going to happen. So I'm going to have to service both of the floppy disk drives, so need to get inside the unit. I've seen a lot of videos of people trying to take HP equipment apart, and it's not actually that difficult, though there seems to be a lot of struggling. First thing is you've got to take the feet off. I'm playing around a bit here trying to find the right screwdriver, because this instrument particularly is a mashup of Torx head and Phillips head screws, and particularly on deep set screws like these, it's a bit of a challenge to find out which screw is used. After much struggling, I found that these were held on by posi drive screws, not Torx head. The other unit that I'm restoring has Torx head in the mounting feet. And here's my first problem with trying to take the lid off. This central screw is always used with the calibration seals for HP units. And what happens is that over the years the stickers build up and the maintenance techs tend to just push the screwdriver through it. So what happens is you get a build up of old calibration stickers at the bottom of the screw, and this causes the screwdriver to come out more and more easily. Eventually the screw gets rounded out and it is a pain to get off. When the lid goes back on, I'm going to have to replace the screw with an M3.5. Fortunately, M3.5, though it's an odd size, is used to fit UK electrical accessories to the wall, so they're readily available here. So we've got to remove the power supply to check for reefer capacitors. There are 6 screws holding it. You can see me taking out one of the PCB screws. There's also a couple on the rails. You've then got to move the PCB back towards the rear of the unit to release it from the motherboard connector. Unfortunately, that doesn't get it out. And here's the first mistake I made. I didn't remove the floppy disk, so that needs to come out. That's held in with 2 Torx head screws. Taking those out releases the plate which is mounting the floppy disk drive. You can then slide the floppy disk drive either back or forward to get it out of the way. So theoretically, once the floppy's out of the way, you've just got to lift up the power supply and pull it forward. Things are never that easy though. I was having trouble with it. I couldn't find the way to get the power supply out as it stood, so I resorted to taking the plastic top cover off. I was going to have to do this anyway to check under it for reefer capacitors and anything else that looked like it'd need replacing. It's important though to replace those pieces of tape once you've put the power supply back together. Those 4 screws are live when the unit's powered up, and you really don't want to be touching them. As you can see, you've also got to remove that single plastic screw. You can then lift the top cover off. And if you look to the left, you can see what's causing the problem. There's a jutting tang on the power supply as part of the metalwork, and that was hooking up. So I'm just now manipulating it to try and get the right angle. There you go. Pull it in slightly and the power supply's out. And this is what we came in for. There weren't any reefer caps, but a Schaffner filter, and those have reefer caps in them. So that's going to be replaced, but that is a simple plug and play. So I'm getting used to sorting out the floppies. Here are 4 from the 2 units. I only actually need to get 2 working for the unit that's staying as a standard 16500A. The one that's being upgraded to a B will lose both floppies. One will be replaced by a 1.44 meg and the other by the hard disk. So first stage is taking off the front panel by releasing the clip on each side. You can then pull the panel off. These, as you can see, aren't yellowed, so they'll not need any retrobrighting. We're then popping off the push button. So once we've got the tops off the drives, the first stage in disassembly is to release the plastic clip that supports the head. You want to be careful that the heads don't bang together as you remove the piece. This then means that the heads are totally separate from the diskette drawer and won't be affected by the work that's being done. Next stage is to release the diskette drawer. So there's a spring on each side that has to be released, and this needs to be done carefully because the spring is quite delicate and easy to distort and also quite easy to lose. So there's the first one off, and if we spin the diskette around we'll see that there's a second one on this side that needs to come off. Once both springs are off, we can pop out the diskette drawer. So you slide the eject mechanism back, and here you can see the problem that we've got, that the ejection plate is spring loaded, but because the grease has gone hard, it won't eject all the way. So pop the spring off, and I'm just moving it around to see how stiff it is, and it was very stiff in this case. So removing the plastic washers, these just pop off and putting them safe. I did try initially with tweezers, but pliers do work a lot better. One thing you will see is that the condition of the two drives is very different. One is almost pristine, the other one is really quite manky, and this is because that one is from the back and has the fans blowing air through it. So now we've got the main mechanism off, the next thing is to remove the side plates. This is simply a matter of unbolting the two plates. You don't particularly need to do it. I've chosen to because I wanted to give them a good scrub and a good clean. The only thing to be careful of when you're taking the sides off and putting them back on is that one screw is longer than the others, and that is the screw that goes through the PCB. It doesn't particularly matter if you get them the wrong way round, but it's better to put it back how it was originally designed. Then once the side plates have been cleaned up, it's a simple matter of screwing them back on. One thing I did do with these is there's a black plastic lever which is part of the ejection mechanism. It's worth taking that off, cleaning the shaft and lubricating it well, just to prevent any problems with stickiness in the mechanism. One thing I didn't say in the previous section is that when you're taking out the diskette drawer, if you can't get the ejection plate out far enough, there is a central position for that black lever, and if you push it to that halfway point and hold it with your hand, you can get the ejection plate just that little bit further back. So starting to put everything back together, first stage is putting the spring back onto the door opening lever. So this lever is pushed up by the insertion of a diskette, and it actually slides open the door to allow access to the media. Just checking that it's nice and free and then lubricating it. I'm tending to use silicone oil on all the rotating parts and lithium grease on the sliding parts, and just making sure that everything is worked well in and has penetrated properly into wherever it needs to go. So you can see there's a little dimple on the arm that rides on the top surface of the diskette drawer. So I'm putting some lithium grease there and just making sure that it's well distributed, so it's giving a nice smooth action to the operation of the lever. It's then just a matter of cleaning off the excess, because you don't want that migrating anywhere near the media. Next part of the process is fitting this little black arm which drops over an axle on the diskette drawer. You've got to get this in the right place. That bit sticking out on the left needs to engage with the raised section on the diskette door arm. If you don't get that right, then the mechanism just won't work properly. You can see there I'm just having a little bit of trouble getting it all lined up. There you see you've got to have the lever slightly forward, otherwise the mechanism locks up and you can't then operate the arm once the thing's together. So that now is working nicely. So the next stage of the process is to get all the rollers well lubricated. I'm using silicone oil again. So there's 4 rollers on the diskette drawer, and those all need to be nicely free running. Once the silicone oil has been injected, it's a matter of working the rollers just to make sure that they spin freely. These are the main motions for the drawer, so it's important that they're very smooth in operation, otherwise the thing's just going to hang up. So here I am just working them by hand to get them going and cleaning off any excess. Once I'm happy they're moving freely, then it's ready for reassembly. So the first part of reassembly is to screw the side plates back on. Remembering of course that you need to get the long screw through the PCB. As you can see, the screw hole near the stepper motor is a little bit awkward. It took me several goes to get it right. Eventually though, I managed to get the screw into place and screwed in. There we go, putting the PCB screw in from the back, not the front. I think that's fairly important to note. And then moving across onto the other side. And again, it's just a simple matter of screwing the side plate in and making sure that it's tight. If you notice, there are little spikes or tabs at the front end of the main casting. This helps you to align the parts. Once the side plates are tightened in nicely, then the next thing to do is to fit the little operating arm. So this arm is triggered by the insertion of a disc, and it's responsible for the cycling of the eject mechanism. So it stops the mechanism dropping when there's no disc in, and then allows the system to cycle when you eject a disc. It's held in by the spring, so it's just quite a simple thing to fix to get it into place. You've just got to watch the spring and make sure it doesn't have any surprises and jump out and hit you, and then put the little plastic retaining washer on top and make sure it's all nice and free. So next phase of the process is reassembling. This is the carrier plate for the ejection system, and this is what had got gummed up. So just checking it slides okay. Now we need to grease it up to get it to run smoothly, so double lithium grease on each of the sliding points, and then a little bit of grease on the pillars that actually hold the tray in place. So then we pop the tray back on, just making sure it's running free, and then pop the retaining washers back on. Once those are in, just checking again, make sure it moves nice and smoothly. And that seems to be very free. So then putting the return spring on. Right, that's just clicked in place. And then just checking again, and what should happen is when you trigger the mechanism, there should be enough ease of movement and force in the spring that that plate pushes itself to the extreme. What was happening before was it was getting stuck halfway. We can then put the caddy for the diskette on. You've got to push the eject button all the way back and then drop the caddy into place. You have to remember to move the black lever out of the way so you can get everything to drop back properly. So that's dropped in. So we then put the springs back on the side. These springs pull the disc caddy down when you put a disc in and shove it into the load position. So just making sure everything's properly in place. That looks like it's set. So the last part of the job is to refit the plastic plate that lifts the head when you eject the disc. This just drops and slides into place. We can then test the mechanism just to make sure it's running nice and free. And there we go. It's inserting and ejecting nicely. So it's now just a matter of putting the plastic pieces back on and the cover, and we're all good to go. So this is the assembled upgrade kit to go from Model A to Model B. At the heart of it is a processor card for the Model B, which I picked up from eBay. They can be got for around £50 to £100 depending. Mine was £50, but by the time I'd paid import duties and shipping, it was closer to £100. This one is a base model with 8 meg of RAM, but it can be easily upgraded by adding in a couple of SIMs, which are available cheaply on the net. In the bottom right corner there's a Dallas timekeeper chip. That's dated 95, so that may be well past its best and will possibly need to be replaced. The connectors of concern which differ between the Model A and Model B are the video connector here. That is a 10-pin connector. On the Model A it's a 40-pin connector. So I've made a little adapter box here to connect the existing Model A monitor onto the Model B. The floppy disk interface here, it's basically the same as the Model A. It's a slightly modified Shugart interface with power taken up what is normally some of the ground pins. The only thing to watch with this as compared to the Model A is the pinout is reversed. On the Model A, the pinout on the main board is opposite to the pinout on the actual floppy disk drives, whereas on the Model B it's the same as on the floppy disk drives. For the upgrade, again, I've made a little adapter here using a similar 3D printed box with a small PCB which I hand wired inside. This basically just links through all the signals and breaks out the power from the ribbon cable onto this separate connector. As you can see here, there's a Gotek that's being used to replace the 1.4 meg floppy drive that I'd bought because I couldn't get that to work for reasons which we'll go into later. The last of the connectors that we need to be concerned with is this one, which is the IDE connector. That's not present on the Model A. I brought this out and I've used it to couple onto this unit here, which is just a standard compact flash to IDE adapter. I put it onto a nice little plate to screw on the back panel and brought the LEDs out onto it. This framework here is just to couple the IDE cable onto the IDE adapter, since they both were sockets. So this is just a simple straight through connector. So here I'm just checking the horizontal and vertical sync signals on the connector on the Model B processor card. This is because there was some ambiguity in the various bits of documentation that I read. so I thought I'd better check them out for myself. Both of them are nice healthy signals, and I came up with this as the required interconnection. The drawing's taken from the service manual for the Model A, and I've marked it up with the corresponding connector positions on the Model B. This allowed me to make the small adapter box so I could go from the 10-way cable for the B to the 40-way cable for the A. So here's a shot of the adapter box for the video connection, just dropped in place and hooked up to the processor board and the monitor, ready for testing so we can see if the processor card works. At this point, if the processor card doesn't boot or shows errors apart from floppy disk and hard disk, then it's game over because there's a fault on the processor board. So it's now just a case of powering up the unit and seeing what happens. So switching on. First challenge is, does the monitor come up? Yep, so we've got a sensible reading on the monitor and the colours are right, so that's the first part. It's now running through the internal self-tests. Bit of a delay, I think that's waiting to try and get a response from the hard drive and the floppy drive, both of which are absent at the moment. And there it comes, everything's passed apart from the two expected failures. So we're good to go on to the next stage. This is the adapter for the floppy disk drive. It's a straight through connector, so one-to-one on all the signals, apart from the 3 wires which are connected by the red wire there. These are the plus 5 volts on the processor board used to power the floppy drive. If you put a standard floppy drive on there without making this modification, you end up just shorting out the 5 volts, which isn't good. So this is setting up to put in the new floppy drive. I sourced some 3.5-inch 1.4 meg floppy drives. I couldn't use the originals because they're 720k and the B expects the high density floppy. So I've got the grey cable is the one that came with the system. That goes through to the processor board. Of course, remembering not to use the original processor connection because it's reversed. So that's using the connection that was for the rear floppy drive when it had the dual floppies on it. So going through the adapter box and on to the floppy disk drive. So trying to boot the unit up, hopefully the floppy drive will seek and it'll report no disk. What actually happened is that, as you'll see, we get a floppy disk failure. After doing a bit of reading around, this is because a PC floppy has a combined disk change and drive ready signal. The ones used by HP have separate drive ready and disk change signals, and it looks like the processor just can't work out what's happening with the floppy, so it just fails it. So the next part of the process is to see if we can get the Gotek to function, since we totally failed to get the floppy drive working. For those of you who've watched my other videos, you'll recognise the casing I've used for the Gotek. It's the same as I used on the HP16500A repair I did in my first video. The only difference is that this time, instead of using HXC 2001, I'm using flash floppy, and I have got a single colour OLED. What I've done is set the drive up with a copy of the startup disk for the 16500B. So I'm just selecting it now while it's doing the self-test, and then hopefully it'll start to boot from it. So after a bit of a delay, hard drive failure as expected, and now we're booting up. So we'll sit here for a while until it boots up. It takes several minutes, mainly because the 1.44 meg runs at half the speed of the 720K drive, and also because there's more data going in with the boot for the 16500B. So we're getting to the end of the boot process, and up comes the machine. So it works, and we can move on to installing the floppy drive and then move on to the hard drive. So here I'm mounting up the Gotek onto the floppy drive mounting plate. All the fun and games over the next section of the video is really around putting in this insulation plate. It's not needed for the Gotek, obviously with a plastic base, but it's the sort of thing that gets lost, and if anybody wants to put the system back to using the original floppy drives without the insulator, they're going to have problems. So now it's mounting up the Gotek. So I've assembled the adapter box that I described at the start of this section and put some double-sided sticky tape on it. This is being mounted up on the rear cover of the front panel, just below where the floppy disk is going to go through it. Once that's stuck in place, the floppy cable's routed out of the way so we can put the drive in. So slipping the floppy drive into place, it can then be screwed down. If you noticed, it's slotted, and that's so you can adjust the position of the front face relative to the front panel, just to get it looking nice and neat. One thing to note is I've omitted the cover that goes over the floppy drive. I didn't think it was necessary, and it just made assembly more difficult. The last part of the process is to connect up the cables and just make sure that they're routed nice and neatly. Once they're in, we can move on to the hard drive. So here's a quick view of the adapter for the compact flash to IDE card. It's a simple gender reverser made using enamelled wire and a small prototyping board. It's just a straightforward one-to-one connection, so pin 1 to pin 1 all the way to pin 40 to pin 40. Here I'm mounting up a plate I 3D printed to take the compact flash to IDE card and the adapter I've just described. The adapter's mounted onto the plate, and then it's got the IDE cable on it ready. It also has a mounting for the adapter box for the video connectors to go from the 10-way on the processor board to the 40 way on the monitor. The plate also has mountings, so I can fix the compact flash so it protrudes through the rear panel. It also has some status lights just so you can monitor performance and see if it's working properly. Once the plate itself is screwed in place, it's a matter of then screwing in the video adapter. The video cables can then be plugged into it and we're ready to move on to the next stage. So we can now screw the compact flash card into the mounting. You can see the socket where it plugs in. This is the front panel that I've printed. It all just then screws in place using M3 bolts. The power connector then has to be plugged onto the processor board to pick up the IDE power feed. So this is with the panel screwed in place, just checking that we can nicely insert and remove the card. So the last stage of the process is to format the hard drive and get the files copied over to it. You can see as it's booted up, it's failed the hard disk test, but this is just because the card is currently unformatted. So I'll skip over the boot process because it takes 2 or 3 minutes and not a lot happens. So there we are, we've booted up. So setting up the configuration, hard drive, it says unsupported format, which is not surprising since it's unformatted. So we go ahead and select the format option and execute it. It now tells us there's no file, so we've got a successfully formatted drive. What we've got to do then is create a directory called system. And then once we've done that, we can copy all the system files into it and we should have a fully functional system. So all that's left to do is see if it'll boot up. So it's coming up, no disk in the floppy, passed the hard disk test, and you'll see the boot's a heck of a lot quicker than it was. I think we've got a successful upgrade to a Model B. If you've enjoyed this video, please like and subscribe. Please give me any comments that you have. Check out the other videos in my channel, and I'll see you next time.